as you're translating these into words, yours could be different from mine could be different from all of you guys's, or you could have some combination. Does anyone want to share what they have for number 1? Jenna. I'm starting this, say again, a number plus 3 multiplied by negative 4. Okay. Now, let's look at this. A number plus 3, so this would be like this, multiplied by negative 4. The way this is written, only 3 is being multiplied by negative 4. So we would need to change that. Felix?
I did sum of a number and 3 times it all by negative 4.
Okay. Sum of a number and what?
And 3 times it all.
So that word all helps a lot with a lot of situations. Yes, that would work. Sum of a number and 3, so I'm adding some x and 3, and I'm multiplying all of it by negative 1. Now, where this is, it kind of looks like this is at the end, but that would be the same thing. Okay.
I think distributed by,
Say that one more time.
distributed by.
So negative 4 distributed by x plus 3.
Well, I did backwards. I did a number plus 3 distributed by negative 4.
I know what you were trying to do with that one. I feel like the only reason that one doesn't work is because when we actually distribute, we would need to like multiply them out, and we haven't done that yet. It's just waiting for us to do that. So maybe not distributed by, but I can see where you're going with that.
What's negative 4 times 4 the number plus 3?
Sorry, say that one more time, but a little slower.
Negative 4 times both a number plus 3.
I feel like that would work. It has that all. So negative 4 times both a number plus 3. I mean, that's it.
Negative 4 multiplied by a number times 3.
So in that case, it would be kind of similar to this one, but it's switched. In that case, the negative 4 is just being multiplied to x and not both of them. Okay, someone? Negative 4 multiplied by the sum of x and 3, that would work. You could have started off with the product of negative 4 and then said something about how x and 3 were being added. Any variation of those. Alright, for A, we'll just get 1 for this one. Go ahead, Felix.
The square root of a number equals 1.
The square root of a number minus 4. See, many of you had something very similar, if not the same thing. Now, how would we say B? Peyton?
Square root of a number and negative
4. Here, the 4 is technically negative, yes, but it's still subtracting. So when you say it like that, the square root of a number and negative 4, I can't really tell what's happening between x and 4. Is that okay? So squared and square root are two different things. If you squared something, that would be me raising it to the second power. That's not the same thing. Michaela? That would work. Because I'm saying the square root of both of these things. So with that first one, we could write it kind of a bunch of different ways, but we have to specify that just the x is being squared. But in that second one, we somehow have to say that everything there is underneath the square root. The square root of both x minus 4, x minus 4, all under the square root. That one you probably wouldn't see as often, but that would probably work. Okay. I'm going to fill this out. You see if yours matches. The difference between a number and 5 is x minus 5. 5 less than that number means 5 comes to the end, so this is again x minus 5. A number less 5 is literally just that, a number less 5. And then the difference between 5 and a number, I'm doing it right as the order says, so 5 and a number. So 3 of them should have been the same, and then that last one was different. Questions on those? Right. We need an algebraic expression for the product of the cube root of 5 and a number.
Cube root is the same as square root, right?
Not exactly. The cube root looks like a square root, but it has a 3, a small 3 on the outside. So kind of, but not really.
Well, I did a square root. I thought it was the same. First, square root of 5 times n, because I thought it was the same, but I just figured out it didn't.
So
So I thought I just be,
if you added the 3 and then say it one more time.
I guess it'll be the cube root of 5 times
X or whatever other. I think I may have, when I walked around, said that they're both underneath, but I think it's just the 5.
Yeah.
Right. And then B, the quotient of a number cubed and 5. Go ahead, Felix.
X cubed.
Cubed and cube root are two different things. Cubed is raising something to the 3rd power. Cube root is, it's like a square root, but with a 3.
So,
Yes.
4A, would it be okay if you put 5 and then the dot?
And sure. Or you could put like this in parentheses. Kind of show that that n is not underneath. I'm gonna kind of walk you guys through this one because I heard some confusion, like you don't know how much the sophomore class is, and that's kind of the point. So in this, high school is having a canned food drive. We know the freshman class collects 54 more than the sophomore. The junior class collected 3 times the number of cans collected by the sophomore class. The senior class collected 10 cans less than the sophomore class. And we're looking for the total number of cans. So there is quite a few things that we don't know. We don't actually know how many cans the freshmen collected, the sophomores collected, the juniors, or the seniors. So I would say pick 4 variables, start with that. So I use F, P, J, and S. the number of cans selected. I'm going to put air quotes saying this would be the same, but by sophomores. This would be the same, but by juniors. And this would be the same, but by seniors. I'll spin you out. You're good. Okay. So we need to look at each one separately and kind of see if we can make an expression for each one first. Okay. So the freshman class selected 54 more than the sophomore class. How could we write an expression for that? Jenna?
I use the same variable for all of them because they number all the sophomore class.
Okay.
I can
So in this case, what we'll find is that you end up using the same variable, but sure. Tell me what you have.
in parentheses as plus 54 as to the power of 3.
Not all of it, this is first part.
Oh, as plus 54.
Okay. I'm going to change mine to P, because that's what I have up here. But to take that a step further, I can say that F equals this. If I knew the number of cans the sophomores had, and I added it to 54, I would get the number of F. What about for the junior class? Okay.
U times 3 equals J.
So J equals 3P for mine. If you have different letters, that's fine. I saw Lee and I saw Lily. Sorry, I like confused you guys' names in my mind. Lee, did you want to answer this next part, and then Lee can answer the last part unless you have to do it. For the senior class, how would you write that? Go ahead, Felix.
I did ask mine.
Because it's less than, and I'm going to use B. So we have some equation for the freshmen, some equation for the juniors, some equation for the seniors. But if we're looking for the total number, what would we do with all of those things?
Add every single class.
Right. So I have, for the freshmen, I have P plus 54. I still need to include the sophomores. I don't know what they are, but that would be just some P. The juniors were 3P, and the seniors were P minus 10. What we're going to do today is figure out how we could combine all of these like terms that we see. You may know how to do that already, and it would be review for you. But we didn't have to actually solve that, so that was all we needed to do. Do you have any questions on that? I'm going to pass. So you may recognize these pieces from when we talked about this last class at the end of class, but just to kind of go over them again, because some of the colors may be different, but they may be the same. Everyone find a big square that looks like this. It does have two sides to it. The blue side is your positive x squared. The red side is your negative x squared. Find the rectangles that look like this. Those are your x's. The green is your positive x. The red is your negative x. And then be careful with the little squares, they like to disappear. But take out one of those, find one of those. Those are your ones. The beige or yellow side is your positive one, and your red side is the negative one. So as we are doing this, I want you to try to make this with your tiles first, and then we'll do it kind of algebraically. I have tiles that can move, so mine will be similar to yours, but a little different. But for you guys, when we don't need it, you can like move it off to the side. I don't have that luxury. Mine goes in the trash. Right? So first, yes, did you have a question?
The blue side is negative.
Blue side is positive. All red is negative. We need to model this. X plus 1 minus 2x. Take a second, model it with your tiles. How would we get x plus 1 minus 2x? The rectangles are your x's. The small squares are your 1's. The big X is your x squared. So right now we don't need the big X squared. Many of you have put those out already. These are your x squared. You need and tell me, how would I model this?
I simplified mine.
Okay, so right now we're not doing that. Just tell me how would I model this entirely.
Oh. And we're gonna have two. You said these are the x's, right?
Yes.
Negative. Two negative red rectangles, and then you're gonna have a small like yellow one, and then you're gonna have one regular x.
So yours should look something like this. 1 positive green, 2 negative greens. I'm sorry. 1 positive x, 2 negative x's, 1 positive 1. Now, to simplify it, we have to get rid of 0 pairs. So think about that as your additive inverse. We're looking for 2 of the same thing that would cancel each other out and become 0. Jenna?
One of the x's, one of the negative x's, and the positive x.
Right. So if you put those together, that is now a 0 pair. As I look at it, they cancel each other out. So you can think about it as like 0 or it's not there. You can move it back off to the side. So when you get rid of that 0 pair, what's left?
1 positive 1 and 1 negative.
So positive 1 and negative x, or negative x plus 1. So we have now simplified that to get negative x plus 1. That would be the answer to that first problem. So write that down if you haven't already. Yes.
So we need to draw the time.
No. So when I originally made these notes, I didn't have these. So everyone was drawing. Okay. We're gonna do a few more with the tiles and then we'll break away from the tiles, but if you still want the tiles or still feel like you need them, feel free to still use them. The next one, 3x minus 4 minus 2x plus 6. Take a second and model those. You may, as we get through some of these, you may not have enough pieces you can share with each other. Okay. And you may still be finishing, that's all right. How would we model this? You can say all or just the keys, Brianna.
We have the green rectangle.
3 green X's.
Four of
4 of your negative ones.
and then 2 negative x's,
2 negative X's.
and then 6 1.
And then 6 positive ones. Same as last time. Now we need to see if we have any 0 pairs. So what I'm going to do is kind of rearrange these. Rearrange these so that each one is kind of next to its own pair. So if I rearrange those, I have all of my X's. Sorry, that was not an X. 2 sets of my X's disappear because they're 0 pairs. 4 sets of my 1's disappear. And this is all I have left. What do I have left? So as you make your 0 pairs, those can be ones you disregard. Okay, I'm not going to count those. Let's do one more of these and then we'll go to a harder one with algebra tiles. So go ahead and model negative 2x plus 3x minus 2 minus 1. And tell me, how would we model that one? But
Negative x's. Positive ones.
3 positive ones.
Oh, sorry, 3 positive x's.
Okay.
Two negative ones. And then 1.
1. What? Get rid of all of your 0 pairs. What do you have left? Felix. X minus 3. On that same page, jump down to this last example. Did you have a question?
Oh, I know the answer.
Hold that thought. Again, you may not have enough to model everything, so you may need to borrow some from your partner or someone at the table. But try to go ahead and take a second, model this. What's the answer to it? X minus 3. Yep. How would we model this? From Felix.
From 2 x's. 2 positive x.
Positive ones.
3.
3 positive ones. 3 negative x squared. 2 negative 1. 1 positive x squared. And 1 negative x. Get rid of all of your 0 pairs. And what do you have left? Brianna? Squared. Or negative 2x squared. There we go. Negative 2x squared. Plus x. Minus 5. 5. I wrote it wrong. That's alright. So, how many ones do you have left? Negative 2x squared, wow, I wrote that really quickly, plus x plus 1. If you wrote that a different way, I want you to get in the mindset of writing it this way. variables with exponents come first, then variables without exponents, and then constants without variables. In that format. I want to say the next page are the same problems, but we're going to do them algebraically. Yes.
Wait, is that a minus one?
It's a plus one. It's just looks. Here. No, it's a plus. Done. Right? There is one more on here that I'm going to let you guys practice in a bit. But on the next page, there are some of the same problems, but now we're going to do them algebraically. We're going to try those ones without the tiles. But if you still want to use the tiles, you can. Okay.
Is it okay that I wrote it different?
For that last one.
Yeah, I have the same numbers.
So in math, this has to be the order in which you write it. The variables with exponents come first, then variables without exponents, then the constant without variables. So after we do this algebraically, then you can kind of pick and choose. Do you like using the algebra tiles? Would you rather do it algebraically? Whichever is easier for you, that's what you're going to use. Right? So for this one, as we're doing this algebraically, and you may know how to do this already, it may be reviewed, that's fine. What are some like terms in this problem? This is kind of going back to that first day activity we did where we had to group terms together by variables and exponents. Kayla.
We have 2x plus 3x is the same, so 1x.
So anytime you have like terms, I would like either somehow circle them, put them in a different shape, or do them in a different color, highlight them in different colors. I'm going to use like, I'm going to box those two together to say that those are like terms. And yeah. And then when you do this, you also need whatever operation comes in front. So if it's negative or positive, you need that as well. Okay, and then, yes, you're just taking the number in front and doing that operation. So negative 2 plus 3 would give you positive 1x. Negative 2 minus 2 would give you a negative 3. If we have an x that has a 1 in front, you won't see that 1 a lot of the time. You'll just see it as x minus 3. But those are the same thing. Any questions on that? Yes.
So the answer would be minus 3.
So I would prefer you write it like this. Know that there's an invisible 1 in front of the x, but don't write it. Now, if you wrote it like on a test, for this upcoming test, it would be wrong. But moving forward, try to avoid doing that. For this next one, what are some like terms? Go, Kayla.
X, negative
X,
and 2x,
negative x, and negative 2x.
negative 1.
And negative 4 and positive 2 would be 1 as well. Or would be separate like terms. So let's combine these like terms. What is 1x minus 2x minus 1x? Priscilla? Yeah. And you can also think about that as I have some additive inverse here. These are going to make that 0 here that cancels. So I'm really just left with negative 2x. And then negative 4 plus 2 is what? Negative 2. So negative 2x minus 2 would be our simplified answer. Any questions on how we got that one? The last one on this is the same one we did before. We're just going to do it now algebraically. There are now 3 different types of terms that are like terms. What are some of my like terms? If you know that's your ringtone, go silence your phone. Kayla, can you hear which pocket that was coming from? It went off now, but. If it rings again, just listen for it. So what are like terms in this? 2x and negative x. So this is really 2x minus 1x, which would give us how many x's? Just 1x or just x. What else are like terms? Go ahead, Priscilla. Negative 3x squared, that was supposed to be a triangle, it does not look like one. And positive x squared. If I have negative 3x squared and I add 1x squared, how many x squared do I have? You guys can say it out loud. Negative 2. So the way I'm writing it now, I may need to fix the order. I'm just writing what I have, or what the answers are. I can find them. And then those last like terms, positive 3 and negative 2. 3 minus 2 would give us 1. Positive 1. So the way I have this right now is not the order we want to see it. Variables with exponents need to come first. Then variables with no exponents. This is a positive, so we're going to add. And then just constants. And if you look back at when we did it with algebra tiles, that should be the same answer. Do we have any questions on the algebra tiles or how to do this algebraically? I'm going to give you guys let's say about 5-ish minutes. You might need a little longer to work through some problems on this page. And then you can go back and do the one problem we didn't do on that first page. But mainly focus on this one. And then we'll come back and do a couple of these together and move on to the next page. But you now have the time to work. You can work with the people around you. If you don't feel like you're going to use the algebra tiles, you can put them back in the bag. All right, let me get your attention back up here. So for examples 1, 3, 2, I don't know why I went out of order like that. 1, 2, and 3. If you need to see those or want to check them, we can do that. I did just want to mention, make sure that when you're doing this, If you remember that these are 1x, so you can still combine those. Anyone want to check their answer for 1, 2, or 3? Priscilla?
Yes.
3 about 14.
If you did want to check your answers, those were the answers for 1, 2, and 3. If you did not get those and aren't sure why you didn't get those, you can raise your hand. We can talk about it. I need you guys to stop building with those because they need to be separate. Put them back in the bags if you're not using them. Yes. Number 4, sure, go ahead.
Oh, so for number 4, I got negative 11a plus b minus 1.
So in number 4, there were a set of like terms that we could combine. But then there was this random b and this random 1 that we couldn't combine with anything. Normally when we have more than one variable, put them in alphabetic order. Alphabetic, sound right. So a, then b, then a constants.
You're allowed to use calculators.
Yeah, so if you want to grab your calculator number, you can. Especially for these ones down here. Maybe helpful to you. I'm going to show you how you would do this on Desmos, and later when you get your phones, you can try it on Desmos, but you can get just your calculator for now. Yes?
Oh, I already saw number 6 in
Okay. Hold that thought, because we're going to go through those together. We're going to go through these together. Great. So for number 5, 1, don't let the fractions freak you out. It's okay that they're there. We're going to simplify this just like any other problem. I see that we have p's, and we also have just numbers that we're going to combine. If you're using your calculator, I usually have a calculator I can pull up, but mine's not working on my screen. To do fractions, if you look where the green alpha button is, if you have this calculator, press the green alpha button. It says alpha on it. And then press the y equals button. So alpha, y equals. You're going to get a menu of like 4 things. I'll repeat that here in 1 second. Anyone else that wants to grab their calculators?
Wait, I have a question. Are we allowed to use calculators in this?
On test? Yes. Yes. Short answer. Yes. So alpha, the green button, and then 2 buttons above that, there's a button that says y equals. Press that button, and you'll get this menu of 4 things that say like n/d, un/d. Don't really remember the last. If you press 1 or enter, you'll get something that looks like a fraction bar with 2 empty spaces. It should look like box, line, box. Does anyone not look like that? y equals. And then you can put in your fraction. Negative 2/3. Don't use the minus button off to the side. Use this little negative at the bottom. And then make sure you come out of the fraction completely. So like your blinking cursor is all the way to the right. Then we want to add 5/6, so put plus, and then do alpha y equals again. If you get lost or get stuck, just raise your hand, I'll come back. And put in the other fraction. When you're adding fractions on this calculator, it will simplify fractions for you, so you don't have to do that. But the fraction you should have gotten when you added negative 2/3 and 5/6 was 1/6. Did anyone not get that?
No, I did get it.
Okay. Jaden?
You can use the calculator. I mean, you can, yeah.
I already know how to do it.
Just punch it in.
What? I just learned in class how to actually do it.
That's like God. Because like, also my room, I have like an office chair. My room is spread out. My brother was staying in and
1/6.
I was like, I'm like, going on my dresser. Like, I'm ready to like, call me.
I want to go back to my class. Me and my brother.
Oh, my little brother was sitting there.
But do you guys know how to solve it, right? You guys know how to solve it spectrally without
Yes. Okay. If you're on your calculator, do the same thing. Do 1/5 minus 1. So alpha y equals, put in 1/5. And then just minus, not the negative.
Oh, 1/6.
You should get the fraction 4/5. Okay. On Desmos, this is a lot easier, and that will be like what you use on like the SOL I'm working to get or to see how we're going to do that test-wise, but we'll cross that bridge when we get to it. In Desmos, so not right now, but this is recorded. You can go back and see it later. You can practice doing this on your phone, on the website. If you have this downloaded as an app, you can do that. If you don't, I would recommend it. It is a good app. I forgot what the two names were. Hold that question for 1 second. Right. So if I put these fractions in here, I can use the minus. And when I press the division button, it automatically changes it to a fraction. And then I just need to come out to the side to add in another fraction. But Desmos likes decimals for whatever reason. So if you press this button on the side, it'll give you that as a fraction. I would say use the graphing calculator. Get used to using the graphing calculator because we'll be using that throughout the year. Do we have any questions on number 5? Say that one more time. You would need to combine the terms. I'm sorry. Get common denominators. So if you wanted to add these without the calculator, I would recommend using your calculator. That way you don't make mistakes because mistakes can happen at any point in time. But if you wanted to do it by hand, these denominators would need to be the same. So if I can change one to be the other, we can do that. I can make 3 become 6 if I multiply this by 2. If we multiply that denominator by 2, I also need to multiply this numerator by 2. So this would become negative 4 over 6 and 5 over 6. And then because our denominators are now the same, we could add them together. Same thing with the 1/5. All whole numbers have an invisible 1 underneath them. So if you rewrite this as a fraction, then the goal is still the same. You want these denominators to be the same. So we're going to multiply this denominator by 5. What I do to the denominator, I also need to do to the numerator. And because they now have the same denominator, I could combine them. So yes, you could definitely do it by hand. If you do it by hand, I would still say check it in your calculator to make sure you didn't mess up. Would we like to do 6 together? Yes. Okay. What are your like terms in number 6? Kayla.
Your 0.5 and your negative k, and your positive 1.5, and your negative 2.
This problem is the same even though they're decimals. We are still just combining like terms. Your calculator or if you could do that mental math, it would be the same thing. So if I'm combining my k's, remember that this is negative 1k. So I'm taking 0.25 and I'm subtracting 1. Or you could kind of switch that around and say negative 1 plus 0.2k. Those would be the same thing. Those of you with calculators, tell me what that would be. negative 0.75K. And then if we add 1.5, if we have positive 1.5 and we subtract 3.5, what would we get? Felix?
2.
Positive 2?
Yeah, positive 2.
Double check. Negative 2?
This
Should
is
be
the
negative
graph.
2.
So 1 cancels that.
Okay, we're going to do this last problem, and that'll be the last thing we do today.
This is always
Bella, you're going to give the answer. Tell me what the like terms are for. I hear a lot of talking, and I really shouldn't. Thank you. Give me the like terms. Right? So with these, the Q fractions are easy to kind of do by hand because they already have the same denominator. So we could just, this would be like negative 1 plus 5, so 4 over 6Q. But then we always need to simplify. You have a simplified answer? 2/3. How is it supposed to be a 3? Alright, and then you have the constant answer? Yeah, what is it?
7/12.
That sounds right. So you could have put that in your calculator or done it by hand, and you would have gotten 7/12. So listen really fast. Before you start packing up, before you continue packing up, listen really fast. Thank you. Next class, we're going to finish the rest of those. You are more than welcome to try any examples ahead of time. But next class will be all of our distributing examples. So have a seat, please. This is about your homework. So please listen. Alright, you do have, so what I'm going to do is not change the dates, but the Delta math that's supposed to be due on Thursday, I would say look at them and try the ones you can. If there are some you can't, that's okay. You can finish those after next class, but I'm going to keep that same due date. You don't need to have them all done before Thursday. I don't even see you on Thursday. I just am giving you extended time on that. The Khan Academy, sorry, I'm trying to see what they are. The combining lecterns with rational coefficients, that's like what we were just doing with the fractions. So you could try that one. That one is still going to be due on Thursday. The combining lecterns with negative coefficients and distribution, you could try that one, but it may make more sense after next class, which again, you would have time to do before Thursday. I promise you guys will have time to pack up and grab your phone for the second. Felix, put your phone back.
No, I'll just run.
Okay, have a seat, please. Right, so I'm not changing those due dates, but don't feel like they all have to be done by the next time I see you. Try what you can. For the Khan Academy, remember that those are actual grades that I put into the grade book. So whatever you get on those is what I put in. You can retry those as many times as you need to get the grade you want. So if you want 100, get 100, and I'll put that in. Evelyn, you had a question. In Khan Academy? Okay. Can you pull that up for me right now so we can go through that? Some of you emailed me with problems like that, like you weren't seeing assignments or not the right assignments.
Yeah.
So for the last 5 minutes, pull that up so I can come around to you. Otherwise, you'll need to either email me or stop by after school or before school so we can figure that out. Question? Huh? Use your passcode. So make sure all of the algebra towels are back in the bags. I will come around and collect those. You can go put your calculators back and grab your phone. Thank you.